Welcome to the deep dive. Today, we're taking a look at something really specific. It's the NTI SE-15V-16-RS-R VGA switch.
Yeah, and our mission here is really to understand the niche for a piece of hardware like this.
Yeah.
It feels like legacy tech, but it's absolutely essential.
Right. It keeps some really important operations running. So at its core, what are we talking about? It lets you connect, what, 16 different computers?
16 sources, yeah, all to a single monitor or a projector or a big LCD screen.
Okay, so the immediate benefit, obviously, is you're getting rid of redundant screens. But, I mean, couldn't a cheap consumer KVM switch do that? Why are institutions paying for this specific model?
And that's the key distinction,
Yeah.
A cheaper switch might save desk space, sure.
Yeah.
But it just won't handle the high-quality video signal you need, especially over the long cable runs you find in, say, a university lecture hall.
Or military settings, I imagine.
Exactly. This unit is built to guarantee that signal integrity across all kinds of systems, PCs, old SUN workstations, MOCs, as long as it's VGA.
And you can see that reflected in the specs, can't you? It supports resolutions up to 1920 by 1200.
Which is perfect for clear presentations. And to handle that across 16 ports, it's got a bandwidth of 150 megahertz.
And the 150 megahertz, that isn't just a number on a spec sheet, is it?
Not at all. It's what ensures you don't get the ghosting or, the signal degradation you'd absolutely see with a cheaper switch.
So let's talk about management. You've got 16 inputs wired up. How do you actually handle the selection without creating chaos?
Well, on the unit itself, you have simple touch buttons on the front with little LED lights to show you what's active.
Okay, simple enough.
But the RS and the model name, that's the important part. It stands for RS232 control.
So remote control.
Exactly. It means an integrator can manage the switch from a computer, change inputs without ever having to physically touch the box. That's a necessity for a secure server room or a busy lab.
And speaking of not causing disruptions, I saw that the monitors are hot pluggable. That seems like a small detail, but I bet it's huge in practice.
Oh, it's critical. It means you can do maintenance or replace a monitor without shutting the whole system down. That kind of flexibility is tied right into its durability.
And NTI designed these things to be daisy-chained.
Right. You can interconnect them with other switches, other splitters for some really complex setups.
Now, this is the stat that really stood out to me. The durability is actually quantified. The mean time between failures, the MTBF, for this 16-port model is, 71,599 hours.
It's an enormous number. And that's why a mission control center or a big training facility pays a premium.
It's the cost of failure.
Precisely. If this switch goes down, the cost of that downtime is just exponential. And that number is backed up by a 2-year warranty and certifications like TAA compliant.
Which tells you it's approved for government and educational purchasing.
Right.
Okay, so just to round it out, logistically, this unit is listed at $615. It's built for racks, comes in a rack mount case. And for a 16-port device, power consumption is surprisingly low, only 10 watts.
So when you put all that together, this NTI switch is just a textbook example of hardware where that specialized function and that guaranteed reliability, it just outweighs the cost.
Totally.
It confirms that in places like training centers or control rooms, you just can't compromise on your switching equipment.
Exactly. And building on that idea of complex applications, the source material mentions pairing the switch with a VGA EDIDE emulator.
Ah, yeah.
If you're not familiar, an EDIDE emulator basically tricks a source computer into thinking a monitor is always connected, even when the switch is looking at a different port.
He just manages the digital handshake between the hardware.
Right. So here's the final thought for you to chew on. What specific mission-critical setting requires both a 16-port switch and another device that's dedicated to mimicking a display's ID? That sounds like a fascinating puzzle to consider the next time you look at specialized infrastructure.